Key skill 6, we're nearly at the end. We've got 3 more examples. Hang in there. We are nearly finished this topic. Okay. Question 1. The remainder of 3x squared plus ax minus 16 is 4 when divided by x plus 5. Find a. This is quite a common exam style question that they give you a polynomial, but it's got some unknown coefficients. So we've got something like an a here, and we have to work out those guys using the remainder theorem. Okay, let's go. So we know that if x plus 5 is equal to 0, x would equal to minus 5. So by the remainder theorem, f of minus 5, well, let's write it in the posh way first. So we know that f of x is divided by x minus a. The remainder is f of a. So for us, we know that when 3x squared plus ax minus 16 is divided by x plus 5, the remainder is, well, it would be f of minus 5. And we know that f of minus 5 is 4 because they've told us that in the question. So now we can set up an equation. We know that the remainder is f of minus 5. F of minus 5 is 3 minus 5 squared plus a times minus 5 minus 16. That's the remainder, which we happen to know is 4. We can put that in. So minus 5 squared is 25. 3 times 25. Minus 5 times a, minus 5a, minus 16. Now we've got a linear equation. We can just solve this simply. So 4 is equal to 75 minus 16 minus 5a. And you can bring everything to one side. So I need a freakish amount of time thinking in my head, what is 75 minus 16? Okay, so 15 minus 6 is 9. So that's 59 minus 5a. Bring the 59 to the other side. 4 minus 59 equals minus 5a. Here we have minus 55 equals minus 5a. We divide by minus 5, which is minus 55 divided by minus 5. A is 11. Now, we're going to put that back in and check that we get the right answer. You're going to see here that the first time I did this, I had a sign mistake. But that's the great thing about checking, because when I put it all into the calculator, you can see I got 114, and I was like, oh, that's not right. It should be 4. So let's check it now. You want to type it all in. 3 times minus 5 squared plus 11 times minus 5 minus 16. So this is f of minus 5, and it should be equal to the remainder, which is 4. Okay, so now we're golden. That one's finished. Let's have a look at question 2. The remainder when 7x squared plus 13x minus 1 is divided by x minus a is 1. Find the possible values of a. Okay, so we know that we always do x minus a equals to 0. So we have x equals to a. So f of x was 7x squared plus 13x minus 1. So if we let x equal to a, we would have f of a equals 7a squared plus 13 times a minus 1. And this is where the remainder should go. We've been told that the remainder is 1. Okay, if you remember, f of a is equal to the remainder r. So we put a 1 here. 7a squared plus 13a minus 1. Okay, this is shaping up to look like a quadratic, and we've got the second hint that says find the possible values, plural, of a. So let's bring everything to one side. That would be minus 2. We've got a non-monic, so we need to multiply 7 times minus 2 is minus 14, plus 13. So the numbers that we're going to split the middle term into are going to be, we're going to do 14 times minus 1 and 14 minus 1. That's going to work. Plus 14a minus 1a minus 2. Okay, so now we're going to factorize the first two by taking out 7a. So that would be a plus 2. And the second two by taking out minus 1. So that would be a plus 2 as well. So my two brackets would be 7a minus 1 and a plus 2, which means my two solutions would be a is 1 over 7 and a is minus 2. I'm going to check both of these by substituting them back into the original equation and checking I get an answer of 1. So 7 times minus 2 squared plus 13 times minus 2 minus 1. That gives an answer of 1. And we can do the same for 1 over 7. Boom, both of them are correct. Now we're on to our very last example. This is a super common exam question. I've seen this many, many times, and you're going to find in your workbooks when you do the previous exam questions a lot of these bad boys. Okay, here we go. X minus 1 is a factor of this equation. Okay, that means that it will leave a 0 remainder. Okay, so we can start here by using the factor theorem with, here we go, with x equals to 1, because you would do x minus 1 equals to 0, so x would be equal to 1. So we know f of 1 is equal to 0. There's no remainder, it's a perfect factor. Okay, so f of 1 is equal to 12, 1 cubed, plus 1 times 1 squared, a times 1 plus b. And f of 1 here is 0 because it's a factor. So that'd be 12 plus 1 plus a plus b. Add these two together and bring it to the other side. And we've got our first equation. Remember, we've got to find a and b. We've got two unknowns. That means we need two equations and two pieces of information. Once we've got the two equations, we can do a simultaneous equation and find both of them. Okay, let's have a look at the second piece of information we were given. We were told that when it's divided by x plus 2, the remainder is minus 4. So in this case, we would do x equals to minus 2. So f of minus 2 is equal to 2 times minus 2 cubed plus minus 2 squared plus a times minus 2 plus b. F of minus 2 would be the remainder from the remainder theorem, and that's minus 54. We can put that in here. Okay, I'm going to type all of these into the calculator to speed this process up. So we've got 12 times by minus 2 cubed plus minus 2 squared, which is just going to be 4. So that's minus 92 minus 2a plus b. Bring that over to the other side. Minus 54 plus 92. So we've got 38 equals minus 2a plus b. So let's set up our simultaneous equation. A plus b is minus 13. Minus 2a plus b is 38. Let's subtract them. A minus minus 2a would be 3a. That would be 0. Then we would have minus 13 minus 38, which would be minus 51. So a would be minus 17, or you can see minus 51 divided by 3. To get b, we just simply substitute in here. So we've got minus 17 plus b is minus 13. B is equal to minus 13 plus 17. B is equal to 4. So there we go. We've got our A and we've got our B. The question asks us nothing else. So we are now completely finished. I hope you've really enjoyed this course. I don't know what we're going to film next. I'm thinking binomial expansion. So stay posted for that. Okay, guys, good luck finishing off this course, and I will see you in the next video, whatever that might be. Bye for now.